Gargi. So today we are going to solve a very interesting problem that is asked in Facebook also. So the problem is that we have to count the good nodes in a binary tree. So the problem statement here says that we have given a binary tree, okay, and that is called as a root. And a node X in the tree is named good if in the path from the root to x there is no good node with a value greater than that the x, so return the number of good nodes in a binary tree. So the problem statement here says that we have given a root, okay, and as you know the logic of a binary tree that the value always lesser values are always in the left side and value that is greater than that the node always in the left side. So as you see that 3 and 3 that is a valid and 1 is basically coming as an invalid because if we are comparing with this case, so 1 is like lesser than the 3, so the logic is not coming here, okay, that's why it's not a valid for the 1. If you're coming to this way, so 1 is like a lesser than the 3, that's why this particular value is not valid here. So we are only counting these four values, so the output is like 4 only, okay. So as you know that good node is like a node is considered to be good only if the value of the node is greater than or equal to the maximum value, okay, from the root to the that particular node, okay. So now we are going to use the approach to solve this problem, that is recursion. So what we are going to do, we are just pass the current node, okay, whatever way we are going. So we will pass the current node and we maximum value seen so far, okay. So if the current value is greater than or equal to the maximum value, we will increment the counter, okay. Whenever we get this particular thing correct, so in that case we just simply increment our counter and we will update the maximum value of the current node value is greater value, okay. And same way we will recursively call for the left and the right side both of the subtree. Fine, let me start with the code and you see that the structure is already there, okay. We just have to write the actual code here. Okay, so let's start. So we will use a helper method here. We just simply first return that count good node. Okay, we name it as like this. And inside this, we will pass root first. After that, we will pass that the value, whatever the result, we will get it. So for the initial case, we will keeping the minimum value inside this. Fine. Now we have to define this. Uh, okay, fine. So private, and it will be of type int only because we are returning int only. Let me copy paste, and it will be of the type. Okay, I'm keeping the name as note and int maxwell. Fine. Inside that, first we have to check the base case. Maybe that root is null, maybe. Okay, so in that case we just simply return 0 because we are returning integer from here. Now we need a counter here, so int count is equal to 0. Fine. Now we have what we have to do, we have to check if the current node is good node or not, okay. So we will check that node dot value, okay, that is node value is greater or equal to that max value. So in that case we are going to put the counter as 1. Right? We have just started that, okay. And after that we will do the count plus equal to, we will recursively call this thing, okay. uh, okay, inside this first we will do for the left side, left comma, inside that we will need a math dot max. We have to find that which particular value is the max, okay. So max value comma node dot value, right? And same we have to do it for the right side. Mm, Fine, this is done now. And after that, whatever value we get it, we just simply return the count from here. Let me run this. Okay, it's got accepted. Let me submit this now. Okay, it's got submitted also. So if you talk about the time complexity here, it will be of n only. Okay, n will be the number of nodes here. And if you talk about the space complexity, so space complexity will be of h only. Fine. So if we conclude that, so to summarize this approach, we just mentioned that we have used that recursion approach here. Okay, and we also use the concept like if we are like go through from the logic. So first we have what we have to did. First we have passed the current node to the maximum value we have seen far. Okay, which we have done here. Okay, and then after that we are just simply what we are doing, we are update the maximum value if the current value is greater than greater. Okay, and same way we are doing for the both cases for the left and right. And after whatever value we are getting from here, there is a counter, so we just simply return it, right? So that's all for today. Hope you like this solution. Okay, thank you for watching. Bye bye.